So let's watch how they solve this problem. It's a classical two-sum problem. It's a classical two-sum problem given an array of integers nums and an integer target return indices of the two numbers such that they add up to the target. You may assume that each input would have a remote solution and you may not use the same element choice. Order. Okay. You can come up with the algorithm that is less than the solution. We have imported java.intel.hashmap. We have also imported, you can see the java intel.mail and can class solution. We take a public integer to some int name and target, create a hash map to store numbers we have seen and their indices. Map integer num map is into new hash map. One per solution O in time complexity for int I is equal to 0. I is less than I is less than num length. The num length less than the I plus plus int complement is equal to target minus I. If the complement exists in our map, if num map dot contain key complement return new int num map dot get complement I, add current number to the map num map dot put num I. No solution found, though the problem guarantees one exists. Return new int. Okay, didn't get anything, right? I didn't get anything, so let's ask Cloud. Can you explain? Beginning. Let's see. Let me explain the two-sum solution in simple terms for someone new to Java. Explain what's the problem you're asking. You have a list of number and the target sum. You need to find two number in the list that add up to the target. We return their position in the list. The simple solution explained in Java. Public int else int to some nums in target map. Okay. Complement return new int number dot get complement I number dot. Here's how it works. I create a memory hash map to remember numbers we have seen and their positions. We go through each number in the list one by one. For each number, we ask what number would I need to add to this to reach the target. This is the complement target minus current number. We check our memory. Have I seen this complement number before? If yes, great. We found our pair. Return both positions. If no, store the current number and its position in your memory and continue. Example walkthrough. Let's say num2 7 11 15 target is 9. Start with an empty memory. Look at the position 0, value is 2. Complement 9 minus 2 is equal to 7. Is 7 in our memory? No. Add 2 to the memory. 2, 0. Look at position 1. The value is 7. Complement 9 minus 7 is equal to 2. This 2 is in our memory? Yes. It is position 0. So return position 0 1. That's it. This approach is effective because we only need to look at each number once, and checking our memory is very fast. Checking. Let me break down the two-sum solution into small code snippet and explain each part in simple English. Setting up the function and creating our memory. Public int to sum. There is first we have done is public int, then we done a third method, give a third bracket to sum. I think it is the name. Int nums and type map. We have a map into here, into here. Some different is name. Num map. New hatch map. Okay, simple explanation. We created a function that takes in a list of numbers in the target sum. We also created a special memory hash map that will help us keep track of numbers we have already seen. Going through each number in the list. For int I is equal to 0. This is I go through go through each number. We are going through each number. Simple solution. We look to look at the each number in our list one by one. The variable I keeps track of which positions we are looking at, finding what number we need to add to reach the target. Int complement is equal to so we have created here. We have created a new variable complement that is target minus num. Okay, if simple explanation for each number we look at, we calculate what is the second number we would need to add to each target. We call it the complement. Checking if we have seen the complement before. If num dot contain key complement, return new int nummap.get complement. I don't get it. Simple explanation, we check our memory. Have we seen this complement before? complement we seen this complement number already? If yes, we have found our answer. We return both position, the position of the complement from our memory and the position of our current number. Remembering the current number, num map the put num I. If we haven't found the match yet, we store the current number and its position in our memory so we can use it later. What if we haven't found a match yet, we store the current number and its position to use it later. Handling the case where no answer is found. Return new int. Simple explanation: if we check it all the numbers and haven't found a pair that works, we return an integer. I get it, but I haven't get this. Happy to explain this to Smith from basic. Creating the hash map. Map in the integer new map is equal to new hash map. This line create new hash map. This line creates something called a hash map, which is like a lookup table. Let me break it down. Map integer. This declare a map that store pairs of integers. To find integer in the key, what we look up, the second integer is the value what we get back. Num map. This is the name we give it to the map. The naming a variable. New hash map. This create a new map, empty hash map. Okay, this will create an empty hash map. So what we are saying here is create a hash map, name new map that gonna have the first integer is the key. What we look up, and the second integer is the value. So what we are saying here that create a hash map. This map, okay. Create a hash map that store integer and integer. This hash map name will be num map, and it is equal to new hash map. So when I create this new hash map, like magic, an empty hash map have been created that will store to integer. In our two-sum solution, we use this map to store keys, the number from our array, value their position indices in our array, the number and the indices, checking and retrieving from the hash map. If a num map dot contain key complement, this code checks if we have seen a specific number before, and if so, return the answer. New map dot contains key complement. This asks is the number complement is or if num map. What is num map? Num map is the hash map we have created. It is num map. What is the name of the hash map that we have created? It was num map. How did we create a hash map? We have created map integer num map is equal to new hash map, then that less than greater than sign, and then first bracket second bracket close. If nummap contain key complement, we have int map complement. If nummap contain key, I think contain key is the number complement is our lookup table of not it returns true or false. It will return true or false. Okay. If none of that contain key complement, if the answer is yes, true, we execute the code if in the curly bracket. Nummap.get complement. Nummap.get complement this derive the position. Nummap.get complement indices where we previously saw the number. Return new and nummap.get complement. I return is create a return a new relative position, the position where we saw the complement number, and the current position I we are looking at. So can I write it? Let's look it up. Import java.util hash map. Import java.util map. Okay. See the solution. Let's write cross solution. Public int to sum into nums and diet. How to do it? Public int public int. What is this? What is this? Into nums and diet. So what we have done is we have created a playground. We have imported the Java util hash map, and we also imported java.util map. We create this class of solution. Then we have this public int to sum. Now we have the nonce and in target. Now what to do? Now create a hash map. Can I create a hash map right now? A hash map of two integer, and that hash map name is nummap, and then create the new hash map. It this. I forgot already. Map. Did I successfully created a hash map here? Let's see. Map, integer. No map is not a new hash map. Yes, map, integer. Did integer spelling is correct? Integer. Integer. For int I equal to 0, I less than greater than non-document I plus plus. Int complement is equal to target minus num sign. Okay. Complement is equal to target minus num I. What is the problem? Oh, hash map. Java.util.hash map. I don't get what is the problem. Java util hash map. This is programming. Cannot find symbol int. Drive Java int red. Solution dot to some. Yes, I get it. Public some some int nums int target. Public int some int nums int target map integer new map num map new hash map map integer num map new hash map. What? Find symbol dot. What is the problem? Already in public to some int nums Same problem line. This could be the problem. Come on! See the specific issue in your code. Let me explain what causing each error and how to fix the method name mismatch. Your method to some method name to some use capital T, but the driver is trying to call to some lowercase t. Java is sensitive to fix them. God damn it, spelling contains key complement. You're declaring the variable as complement, but you're using complement. Okay, so there are many issues. First issue is your method is calling to some. I name it to some when my method is calling Some spelling error, contains key. It should be contains key. Contains key. Next, spelling error, complement. Your declared a variable as complement but using complement. 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 Code structure issue num.py.put nummap.put. This line is outside your for loop, so I is no longer in scope. Move this line inside the for loop before the end of the loop. Space missing, new int should be new int 0 space new int 0 this space num.put it should be inside of this. Yeah. Finally. Finally.